Okay, so just further on the hyperbola, I just want to do vertical and horizontal shifting within the same function. So say you have y equals 1 over x plus 1, and then you go plus 2. So you have two types of shifting here. One, you have the effect of this x plus 1 here, and the other one you have the plus 2. So when you're looking at these here, basically this one here, this is inside the function, so it's like having f of x plus 1. So you do the opposite sign, so this would move left to minus 1, okay, and it would be a horizontal shift. It will affect our asymptote. So it'll affect the x value of the asymptote. So our new asymptote will become x equals minus 1 when it shifts to the left. This one here, the plus 2, that's like having, if you get your function, whatever your function is, and you add 2, that means it will go up 2. Okay, so that will actually be a vertical shift. So it'll shift vertically too. And it will affect the asymptote in the fact that the new asymptote would be y equals 2, because it's going to move up to y equals 2. Now if we put that into practice on our curve, so it's going to go to the left to minus 1, and it's going to go up 2. So you go like this, and left to minus 1 and up 2. Then if you look at that, that would be your new curve. So just further on that, it's going to go up to 2. Okay, so it went up 2, and then it's going to go to the left. So it moved to the left to minus 1. So now when we're looking at that, let's look at the domain. So the domain would basically be it's all real x, except x can never equal minus 1. And if you think about that in your equation, the one value of x that it can never take on would be minus 1, because if you put a minus 1 in place of that there, you'd have 1 over minus 1 plus 2. So you have 1 over 0 plus 2. So can you see that if you look at that, the x value can never equal minus 1 because it'll make the denominator 0. So putting that into interval notation, that would mean that that would be minus infinity to minus 1, and then it would be minus 1 to infinity. Now if you're doing the range would be all real y. Now if you think about that and you're looking at it, all real y, so we can get y up here above 2, and you can get y below 2, but the one value of y that you can never have is y equals 2. Okay, so it's all real y except y equals 2. Now I want you to also think about this, just to extend your thoughts. If you think about this in relation to the equation, because this here can never equal 0, like that there can never equal 0, as x gets bigger and bigger and bigger, you're going to approach the number 2. Okay, because as x gets bigger, the denominator, like, say you put 1,000 in there, 1,001 plus 2, the denominator of that is going to get so small that it will never, like this here, it'll get so small that it'll get closer and closer to 0. It'll never actually hit 0. So it's always going to be 2 plus a really small number. So the asymptote is actually just going to get closer and closer to 2. And that's what's happening graphically up here as well. Now, when you put that into interval notation, that would be minus infinity to 2. And that would be 2 up to infinity.